Cathode compartment. What does a cathode have? What's doing the? No, the cathode doesn't. The cathode has a plus symbol. The plus symbol means electron rich or electron poor. What is electron poor in the cathode compartment? The cathode has the oxidizer. What is the oxidizer here? Copper metal or copper 2 plus? Copper 2 plus. The copper 2 plus needs to take the electrons. It's going to take the electrons from the anode. But the job of the cathode, this is copper metal. The copper 2 is in solution. How is it going to take the electrons from zinc? It needs some kind of electrical conductor. The job of the cathode here is to feed the electrons to copper 2. And so all it has to be is an electrical conductor. Well, the problem is zinc will feed electrons to copper 2, but the problem is here. If you put zinc over here, then the copper 2 will oxidize the zinc directly. And the electrons are not going to flow through the wire. The electrons are going to just go straight from the zinc to the copper. In fact, that's what we see here. Oh, no, we don't see that. You would see something like this. You know, if this strip were zinc, then we'd have a buildup of copper metal on it. So what does the cathode have to do? It has to feed electrons. Is copper a reactant in this reaction? No. And so what we need is an inert electrode that feeds electrons. Well, copper will be inert because copper is not going to be oxidized here. And so copper is okay, the zinc is bad. How about platinum? Will platinum feed electrons to copper 2 ions? Platinum is an excellent electrical conductor, and it's unreactive. The copper 2 is not going to attack it. All it's going to do is take the electrons. Not from platinum, because platinum is getting electrons from zinc. And so platinum 2 is acceptable. So the answer is B, C. In fact, platinum is a very common electrode material. When I was at UCSB, we had 3 drawers full of gold and platinum electrodes. You know, and those platinum electrodes were heavy, like a pound or 2. That was like a pound of platinum. Can you believe that? That was back when platinum was much cheaper, and it wasn't even locked. Anybody could have walked in there and taken it. Pounds of platinum and gold. My God. Like, with that, how much platinum and gold in there, I could be retired by now, probably. But anyway, I'm sure it's all locked. It's probably in a safe right now, vault. But platinum is very common electrode material because it's so unreactive. It just feeds electrons or pulls electrons in. How about silver? Silver would be fine. Oh, actually, no. Copper is bad. Copper is bad because we're feeding it to silver ions. Silver can take, in fact, this is why I went back to this. I've got it mixed up, sorry. If we tried to use copper as an electrode, this would be what would happen. The silver would take the electrons straight from the copper electrode itself. And so we wouldn't be drawing any electrons through an external circuit. So sorry, I got it mixed up for a second. And so zinc and copper would be called reactive electrodes. We don't want those. We want an inert electrode. So platinum would work. Silver would be fine because silver versus silver is a tie. And so silver would probably be the best choice because who wants silver-coated platinum? Do you? Usually people want it the other way. They want gold-plated whatever, or platinum-plated this, you know? And so they want to plate their cheap metal with precious metal. not the other way around. They don't want to plate their precious metal with cheap metal. And so the platinum would work, silver would work, and graphite. Did I talk about graphite? Graphite is an electrical conductor, and it's really hard to oxidize. Graphite isn't as good of an electrical conductor as copper, platinum, or gold, but it's decent. The reason being is graphite, forms layers, and is what we call a two-dimensional conductor. And so it conducts very well in the plane of the layers. In the XY plane, it conducts as good as copper. But in the Z direction, which is perpendicular to the layers, it's an insulator. And so, but still, it works pretty well, and it's cheap. And so for us, we don't have a drawer full of platinum electrodes. We have a drawer full of graphite electrodes here at El Camino. In fact, we're going to use those next week when we do this. All right, so let's go for this. For the reaction copper, same reaction, circle all suitable anodes. So A, zinc. Anybody select zinc?
Yeah.
Zinc is no good. Zinc is no good because which has a higher oxidation potential? Copper or zinc? Which one's easier to oxidize, copper or zinc? If somebody, hey, I have a zinc ring versus a copper ring, which one's better? Copper, for sure. Copper is a coinage metal. Zinc is easily corroded. Zinc has a very high oxidation potential compared to copper. Copper has a lower oxidation potential. Zinc has a higher oxidation potential. The higher the potential, the more likely it is to occur. So zinc's oxidation potential is like plus 0.7 volts. Copper's oxidation potential is plus 0.34 volts. Zinc is much higher. So if we use zinc, we aren't going to get this reaction. What we're going to get is all the electrons are going to be coming from zinc. And so we're going to get zinc goes to Zn2+, and the copper is going to stay fine. And so it would be a mistake to use zinc. On the other hand, we could use copper. That's fine. If we use copper, that's what we have here. We're using a copper electrode. This is good because this is a dual-purpose electrode. One, it feeds the electrons over to the cathode. Two, the copper acts as the reactant because in this, we take the copper metal and form copper 2+, in the process generating electrons. And so copper is good for this. Okay, then we have platinum. Could we use platinum? Sure, we could use platinum, but this is a single-purpose electrode. The purpose of this would just be to take the electrons and feed them over to the cathode, right? And so this would be an electrical conductor. If we use platinum, we still have to attach a chunk of copper to that. Well, if we attach a chunk of copper to platinum, then platinum is just acting as a piece of wire, a very expensive piece of wire. We don't need that expensive piece of wire. We can just use regular copper wire for that. And so it makes no sense to use platinum. We might as well just use copper metal because we still have to use copper metal because copper metal is the reactant at the anode. The same thing can be said of silver, and the same thing can be said of graphite. And so the only sensible choice here would be B, copper. All right, to keep the classes in sync, let's skip the multiple choice, and I'm going to give you 5 minutes to do this. 5 or 10 minutes to do this. We are going to do the extra credit, but the extra credit is going to come at the very end. The extra credit I'm going to have at the end, so some people will finish early, some people will finish. You can take as much time as you want for the extra credit. But some people finished in less than 1 minute, and so I'm not going to spend a whole bunch of time for that extra credit. But let's take a look at this. Okay, this is the cell diagram. I want you to sketch a drawing of the cell. And so, and then the cell diagram is missing a lot of details, like what the salt bridge is, which way the electrons flow, what's the anode, what's the cathode. And so what I want you to do is sketch a diagram of the cell, a drawing of the cell like we did earlier. I shouldn't say diagram because this is the diagram, technically. And so I want you to sketch a drawing of the cell showing all the features. of that cell. And so why don't you do that? I'm going to give you 5 minutes to do that, and then we'll take the quiz.